हरिः कन्ना।
Now let's look into the third type of level of measurement, that is interval. Interval level of measurement is a type of quantitative measurement where the data is measured on a scale where equal intervals between values represent equal differences in the underlying attribute being measured. But there is no 0 point. So, unlike the ordinal scale, however, the interval scale has a known and equal distance between each value on the scale. Imagine the points on a thermometer. So, unlike the ratio scale, the fourth level of measurement, interval data has no true zero. In other words, a value of 0 on an interval scale does not mean the variable is absent. This is best explained using temperature as an example. A temperature of 0 degrees Fahrenheit does not mean there is no temperature to be measured. Rather, it signifies a very low or cold temperature. So now let's look into some of the examples of interval data. So here you can see examples of interval data include temperature in degrees Fahrenheit or Celsius but not Kelvin, and intelligent coefficient score from 40 to 160, or income ranges, income categorized as ranges. So example 19 to 29 kilo $29,000, and 30 to $39,000, and 40 to $49,000, and so on and so forth. So now the question arises, how to analyze interval data. How is interval data analyzed? So one of the first steps in the data analysis process is to summarize your data. For interval data, you can obtain the following descriptive statistics, which are frequency distribution, mode, median and mean, range, standard deviation and variance. So let me put it in our Jupyter editor. So this is interval level of measurement. So the descriptive statistics that we can use, or the measures of descriptive statistics that we can use with the interval data, are, as usual, the first one remains same: frequency distribution. Then central tendency, the measure of central tendency, the mode, median and mean, and range, standard deviation, and finally variance. So these are the descriptive statistical measures that we can use with interval data. As we saw previously with nominal and ordinal data, frequency distribution presents a summary of the data in a table, allowing you to see how frequently each value occurs. That's what the frequency distribution is. Nothing but the table or the histogram allows you to see how frequently each value occurs, either as a count or as a percentage. So, and the second one we have is the mode, median and mean, are or all measures of central tendency, the mode is the most frequently occurring value, the median is the middle value, uh, and the mean is the average of all values. So to calculate the mean, add all values together and then divide by the total number of values. We will be looking into that. Then we have a range, standard deviation and variance. This talks about the variability of data, or this is called the measurement of variability. So variance looks at uh, variance are all measures of variability within your data set. You can calculate the range by subtracting the lowest value in your data set from the highest. So standard deviation calculates on average how much each individual score deviates from the mean. So standard deviation calculates on average how much each individual score deviates from the mean, allowing you to gauge how your data are distributed. Whereas variance looks at how far and wide the numbers in a given data set are spread from their average value. These concepts can be confusing for now, so we will be exploring all these concepts, all these statistical measures in detail in the next course, that's Intuitive Statistics for you. So till then, you just try to grasp the statistical measure names and try to understand whatever you see on the screen, and later you can explore in detail in my another course. So then we have the statistical tests. So statistical tests for analyzing interval data. So as long as your interval data are normally distributed, you have the option of running both parametric and non-parametric tests. However, parametric tests are more powerful, so we will focus on those. Here are, let me write some of the parametric tests. So this is descriptive statistics, and let me write down parametric and non-parametric tests, or simply I can mention the statistical tests. So the first one is t-test, or simply t-test. So t-test to compare the mean values of two data samples. T-test is to compare the mean values of two data samples. For example, what is the difference in the average IQ score of 40 50 years 40 to 50 years old livings in London and Leeds? And the second one we have is ANOVA. So ANOVA test to compare the mean values across 3 or more samples of data. So for example, what is the difference in the average IQ score for 40 to 50-year-olds living in London, Leeds and Birmingham? So total 3 categories. It will be comparing between 3 samples or 3 or more samples of data. If it is 2 samples of data, we will use t-test. If it is more than 2 samples, we use ANOVA. Then we have Pearson's R. Pearson's R to see if there is a correlation between two variables. For example, is there a relationship between a Pearson's income range and their IQ score? And we have a simple linear regression. So linear regression to model or predict the relationship between two variables or the impact of one variable on another. For example, can a Pearson's IQ score be used to predict their salary range? So that's what the linear regression talks about. And these are the tools that we can use to do the analysis on interval level of measurement or interval data.